हेलो स्टूडेंट्स, वेलकम टू एन अकेडमी नया आगाज सीरीज ऑफ ऑपरेटिंग सिस्टम कोर्स। और आज का हमारा टॉपिक है डेडलॉक्स। सो बॉयज एंड गर्ल्स, सो फार हमने देखा इंट्रोडक्शन एंड बैकग्राउंड, जहां पर हमने बात की व्हाट इज ऑपरेटिंग सिस्टम, फंक्शंस एंड गोल्स, और फिर टाइप्स ऑफ ऑपरेटिंग सिस्टम प्राइमरली लाइक प्रीएम्प्टिव एंड नॉन प्रीएम्प्टिव, यूनी प्रोग्रामिंग एंड मल्टी प्रोग्रामिंग। एंड सब्सिक्वेंटली हमने कॉन्सेप्ट ऑफ सिस्टम कॉल्स देखा, फोक सिस्टम कॉल के बारे में पढ़ा, एंड देन इवेंचुअली वी स्टार्टेड विद प्रोसेस मैनेजमेंट, जहां पर हमने डिटेल में डिस्कशन किया विद रिगार्ड टू प्रोसेस कॉन्सेप्ट्स, followed by CPU scheduling, followed by process synchronization, right? And IPC, classical IPC problems भी हमने solve किए, हमने देखे, and today onwards we are going to start with the last chapter of process management जिसका नाम है deadlocks. Deadlock is not a new feature for you. Deadlock के बारे में हमने already पढ़ा कि deadlock is one of the undesirable feature of operating system. Deadlock happens when processes get stuck. Deadlock happens when processes get blocked forever. Infinite blocking is deadlock. Indefinite blocking is starvation. तो starvation and deadlock दोनों somewhat related है, लेकिन fundamentally there is a difference. There is a difference between them. So infinite blocking, blocking forever, is deadlock, and indefinite blocking is starvation. So let's see the definition of deadlock. What is the formal definition of deadlock? So, but before that, this is my again emphasizing official Telegram channel. Just in case if you have not subscribed, you can do so. So first point I would like to make a mention. So let me write the heading as deadlock. Right. So is deadlocks. So first we'll make a definition, formal definition. We say that two or more processes are said to be in deadlock, if and only if they wait for the happening of an event which would never happen. अगर ये कॉन्सेप्ट को समझने के लिए हम एक डायग्राम ले लेंगे ताकि आपको समझने में आसानी हो. इमेजिन देयर आर टू प्रोसेसेस एंड फर्दर वी इमेजिन देयर आर टू रिसोर्सेस. देखिए, रिसोर्स कैन बी हार्डवेयर और सॉफ्टवेयर लाइक प्रोसेसर, मेमोरी है, रजिस्टर है. दीज आर एग्जांपल ऑफ रिसोर्सेस. So I say this process I, this process J, this is some resource A and this is some resource B. So imagine, for example, this process Pi is holding this resource and process Pj is holding this resource. इसके बाद अगर हम कहें कि this process Pi is making a request for resource RB, I'll put a request like this, and process J say I want RA. तो मतलब यह है कि process Pi is holding RA and requesting RB. वो कह रहा है कि in addition to RA मुझे RB भी चाहिए. और उसी तरह process J कह रहा है apart from having RB, I want RA. So eventually we can say that, listen to me. Pi is waiting. Eventually I can say that Pi is waiting on Pj and Pj is waiting on Pi. दोनों आपस में एक दूसरे के ऊपर वेट कर रहे हैं. Pi is waiting on Pj for resource RB. Why? Because RB is in use by Pj. and Pj is waiting on Pi for resource Ra because Ra is in use by process Pi. So ये है condition of deadlock. Eventually, deadlock can also be explained by means of a simple semaphore scenario, semaphore based scenario. कैसे? Imagine I have two binary semaphores. Let us call Sx equal to 1 and Sy equal to 1. There are two binary semaphores by name Sx and Sy. Sx is initialized to 1, Sy is also initialized to 1. Now imagine for example, I have two processes, Pri. Pri perform down on Sx and the process Prj perform down on Sy. And subsequently इसके बाद ये process perform करेगा Sy down on Sy and this process will perform down on Sx. दोनों आपस में एक दूसरे पर depend कर रहे हैं. This is a clear deadlock like situation between the processes I and J. ये है दोनों में deadlock. कब होगा deadlock? If process Pi get preempted after performing down of X. If process Py Pj get preempted after performing S of Y, down on S of Y. So यहाँ पर अगर preempt हो जाए after performing this down, then eventually both the processes will get stuck, involved into a deadlock. Deadlock is said to be an undesirable feature of operating system. Let me write it for your note. As a note I will write. Deadlock is an undesirable feature of OS. Deadlock is an undesirable feature. Deadlock is an undesirable feature of operating system. Why? क्यों deadlock is undesirable है? इसलिए undesirable है कि when deadlock happen, processes get blocked. Look, Pi got blocked, Pj got blocked. They are not simply blocked, but they are holding the resources and get blocked. मसला ये है, problem ये है कि they are not simply blocked. They are holding and not allowing other processes to use the resources. अब ये जो resources है Ra and Rb, they got stuck, they got blocked with the processes forever, not allowing other processes to use. Resource utilization, throughput, efficiency will come down. So therefore, the eventuality of deadlock, the consequence of deadlock is that it will lead to ineffective utilization of resource. Ineffective utilization of resources. And it will lead to minimization of throughput. Minimization of throughput. क्योंकि processes block हो जाएंगे. So for these reasons we say deadlock is not a desirable situation. When deadlock happen, processes not only get blocked, but they hold the resources and get blocked, thereby not allowing other processes to use the resources. So resource utilization will drastically come down, and efficiency, throughput levels will also come down. तो हमें concrete strategy होना चाहिए to deal with the problem of deadlock. We need to have concrete strategies for dealing with the problem of deadlock. So deadlock handling strategies discussion start करने से पहले हमें ये देखना होगा कि what are the necessary things, groundwork क्या है, right? So for that we will make a basic discussion on what is called system model. मतलब what kind of system are we assuming for the study of deadlock handling? System की characteristic क्या होना चाहिए for the study of deadlock handling? We all always assume that the system will have finite number of resources and finite number of processes. P1 to Pn. Finite resources and finite processes. Resources can be hardware and software. Resource types may be R1, R2, so on, Rn. The resources may be CPU, memory, input, output devices. और ये भी हम assume करेंगे हमारे system model में each resource may have multiple instances. Instances का मतलब है copies. जैसा कि एक register है, register is a resource. I may have multiple copies of resource. I may have multiple registers. एक processor है, resource है. अगर एक ही CPU है मेरे system में, single instance resource. So boys and girls, a resource may have one instance or a resource may have multiple instances. A resource may have one instance or a resource may have multiple instances. Then finally, जो हमारा working model है, working model जो है वो ये है. Working model of what? Working model of using the resource. A process cannot start straight away start using the resource. No. Process will have to make a request to the operating system for the resource, because operating system is the resource manager. तो process को request करना होगा for the resource. Then based on the request, the operating system may grant the request, may deny the request. अगर resource available है और operating system ये resource grant कर सकता है, it will grant. अगर resource grant हो जाए, process will use the resource. और usage होने के बाद process will release the resource. अगर for example मान लीजिए कि operating system for some reason cannot grant, then the process get blocked. It will remain in block state till it is granted. अगर process is remaining in block state for indefinite time, तो हम वो बोलेंगे starvation है. या फिर अगर process is remaining in block state forever, फिर हम बोलेंगे deadlock. तो ये डायग्राम जनरली मैं अपने तौर से स्टूडेंट्स के समझाने के लिए ऐसे बनाता हूं. I can explain it by means of a simple diagram. So imagine this is the process, okay, and this is the operating system. So initially I would say that this is a process, this is the operating system. The process will request for the resource to operating system. The operating system may grant or may deny. So I say this is deny. Then the process will wait here. And if it is granted, if it is this grant, then the process will use the resource. और जैसे ही usage complete हो जाएगा, the process will release the resource back to operating system. उसी तरह the process wait till it is granted. जब grant हो जाएगी, the process will again use. This grant is in finite time. नहीं, अगर process is remaining for long waiting in this waiting state, this is called starvation. Prolonged indefinite waiting is starvation. लेकिन अगर process is remaining in waiting state forever, या आप बोलोगे forever infinite waiting, then this situation will be termed, this situation will be defined as deadlock. ये है deadlock. This is the conceptualization of the system model. Conceptualization of system model, boys and girls. So therefore the cycle is request, use and release as per the model. So सारे deadlock handling strategies is going to abide by, is going to follow this discipline among the processes and operating system. तो चलिए आगे बढ़ेंगे. Next, this is a simple example to show a deadlock happening between two threads T1 and T2, two processes between T1 and T2. There are two semaphores S1 and S2. S1 is initialized to 1, S2 is initialized to 2. Process P1 is performing down operation on S1 followed by down operation S2. जो अभी हमने कहा था वही है, जिस performing down on S2 then down on S1. तो अगर रिवर्स ऑर्डर में परफॉर्म कर रहे हैं डाउन ऑपरेशन प्रोसेसेस, इवेंचुअलिटी इज डेडलॉक, कॉन्सिक्वेंस इज डेडलॉक. तो ये सिंपल एग्जांपल है. देन द नेक्स्ट थिंग दैट वी नीड टू लर्न विथ रिगार्ड टू डेडलॉक हैंडलिंग, वो है डेडलॉक कैरेक्टराइजेशन. डेडलॉक कैरेक्टराइजेशन deadlock characterization. So let's study this. Deadlock characterization. So as part of characterization, we are going to study two things. The first one is called necessary conditions. What are the necessary conditions to be present in the system in order for deadlock to happen? देखिएगा, कोई भी प्रॉब्लम होने के लिए हमें कुछ ना कुछ नेसेसरी कंडीशन होना चाहिए. आई यूज्ड टू से, फॉर एग्जांपल, एक डिजीज है लाइक मलेरिया, कंटेजियस डिजीज है, फॉर एग्जांपल मलेरिया. सो इन एनी एरिया इफ मलेरिया इज टू हैपन, अगर मलेरिया होना है कोई एरिया में, देन व्हाट इज द नेसेसरी कंडीशन? तो हम बोलेंगे कि सर वी शुड हैव मस्किटोस, वी शुड हैव स्टैग्नेंट वाटर, we should have untidiness. These are necessary conditions. These are necessary conditions for the disease malaria to erupt in any area. अगर ये कंडीशंस ना हो तो डिजीज नहीं होगी, लेकिन ये कंडीशंस अगर प्रिवेलिंग हो, अगर एग्जिस्टिंग हो सकता है डिजीज हो, ये मतलब है नेसेसरी कंडीशंस. ऑलवेज देयर आर टू थिंग्स, वन इज कॉल्ड नेसेसरी कंडीशंस और दूसरा है नेसेसरी एंड सफिशिएंट कंडीशन. नेसेसरी का मतलब यह है कि दीज आर नेसेसरी फॉर द प्रॉब्लम टू अराइज. नेसेसरी कंडीशन का मतलब, नेसेसरी एंड सफिशिएंट का मतलब यह है कि जब भी वो कंडीशंस होंगे तो प्रॉब्लम कंपलसरी होगा, वो है नेसेसरी एंड सफिशिएंट. सो दीज आर ओनली नेसेसरी कंडीशंस. मतलब जब भी ये कंडीशंस प्रिवेलिंग होंगे, एग्जिस्टिंग होंगे, तो मतलब प्रॉब्लम होने के चांसेस है, प्रॉब्लम में हैपन. सो व्हाट आर दोज नेसेसरी कंडीशन? देयर आर 4 necessary conditions, boys and girls. There are 4 necessary conditions to exist in the system in order for a deadlock to happen. In order for a deadlock to happen. The first necessary condition, let me write it here, let us discuss. First one, mutual exclusion. जहां पर भी वर्ड थ्रेड हो, आप इक्वलेंटली उसे रिप्लेस कर सकते हो प्रोसेस से. ओनली वन प्रोसेस एट ए टाइम कैन यूज अ रिसोर्स. मतलब यह है, for the first and foremost condition, necessary condition for a deadlock to happen is that there must be some shared resources. अगर shared resources ना हो, critical section ना हो, तो deadlock नहीं होगा. क्यों? क्योंकि communication ही नहीं है. अगर कोई communication ना हो between processes, how can deadlock arise? So some resources, like in previous example आप देखो, process I is holding RA and process J also want RA. Shareable होना चाहिए. अगर हम कहें कि resource is to be used only by one process, other process will never use the resource, why will problem arise? Problem नहीं होगा. तो mutual exclusion principle जब होगा, existing होगा, तब ही deadlock की possibility है. Second, hold and wait. A situation where a process is holding, thread is holding some resource and waiting for another resource, that is called hold and wait. देखिएगा डायग्राम, पिछला डायग्राम हमने जो यहां पर ड्रॉ किया था. PI is holding RA and waiting for RB. PJ is holding RB and waiting for RA. जब तक होल्ड एंड वेट ना हो तब तक प्रॉब्लम नहीं होगा. जब तक होल्ड एंड वेट कंडीशन एग्जिस्ट ना हो, डेडलॉक नहीं हो सकता. फॉर एवरी डेडलॉक देयर मस्ट बी होल्ड एंड वेट. तो मतलब हम ये कह सकते हैं कि इफ देयर इज होल्ड एंड वेट, देयर इज अ पॉसिबिलिटी ऑफ डेडलॉक. डेडलॉक हो सकता है, बट इफ देयर इज नो डेडलॉक, होल्ड एंड वेट नहीं होगा. अदरवाइज if there is hold and wait, deadlock may or may not happen. But if deadlock is there, hold and wait should be there. Next, no preemption. That means that hold and wait will lead to deadlock. That hold and wait will lead to deadlock if there is no preemption of resource. Follow me. That means PI cannot take away RB from PJ. PJ cannot take away RA from PI. Then only I will have deadlock. Agar if we allow preemption, if we allow processes to preempt their resources, why will deadlock happen? So no preemption become the necessary condition for a deadlock to happen, boys and girls. No preemption. Third condition. Finally, the last condition for a deadlock to happen is circularity among threads or among processes. Processes or threads must form a cycle among themselves. अगर आप गौर करो यहाँ पर, तो you can find that there is a cycle among the processes. PI and PJ are waiting for each other, and that is forming a cycle among themselves. Like for example, if I have more processes, then I can have a big cycle. PI is waiting on PJ, imagine. PJ is waiting on PK, and PK is waiting on PL, and PL is waiting on PI. ये है circularity, circular wait. Processes must form a cycle among themselves in order for a deadlock to happen. Every cycle is not deadlock, but every deadlock implies the presence and existence of cycle. Presence and existence of cycle. There exists a set of processes or threads of waiting such that T0 is waiting for a resource that is held by T1. T1 is waiting for a resource held by T2, and so on. Cyclic condition होना जरूरी है. Right? So this is about the necessary conditions. जब नेक्स्ट हमारा कैरेक्टराइजेशन है टू कैरेक्टराइज डेडलॉक, वो एक टूल है विच विल हेल्प इन स्टडी ऑफ डेडलॉक हैंडलिंग, एंड दैट टूल इज कॉल्ड रिसोर्स एलोकेशन ग्राफ. लेट मी राइट इट हियर. रिसोर्स एलोकेशन ग्राफ. Resource allocation graph. Let's underline this. We write in short RAG. This resource allocation graph will help characterize deadlock. will help in many deadlock handling strategies. So what is this tool by name RAG? Let's make a discussion. Let's make a definition. Generally, we define a graph having two things, a tuple with two parameters, V and E, set of vertices and set of edges. So like any other graph, resource allocation graph also has a set of vertices and set of edges. Let me tell you, vertices in resource allocation graph are of two types. One is process vertex and the other is resource vertex. Process vertex is generally designated or shown by means of a circle like this, and you can write the name of the process PI. Resource vertex is indicated by means of a square or rectangle, right? Square or rectangle, and name of the resource say RA. Because resources हमने देखा are of two types, single instance and multi instance. दो types of resources है, single instance and multi instance. Single instance मतलब it has only one copy, so therefore single instance is indicated with a square and one dot. Multi instance is indicated with a square and multiple dots, like I have multiple copies. So this resource RA has only one copy. This resource RB has three copies. 1, 2, 3. 3 copies. Single instance, multi instance. So boys and girls, these are two types of vertices. Likewise, the edges in the graph, boys and girls, please follow. The edges in the graph are of three types. एक हम कहेंगे claim edge, दूसरा है request edge और तीसरा है assigned or allocated edge. Claim का मतलब यह है कि the process may require this resource in future. So it will go from process to resource in the form of a broken line. It will go in the form of a broken line, something like this. This from process I to resource A. इसका मतलब यह है कि this particular process may request this resource in future. Claim may request, शायद हो सकता है future में पूछे. Now I have other is request. जब process will really make a request for the resource. जब process physically request पूछेगा resource के लिए, right? Then that is going to be converted into request edge. So this is request edge. So this is process PI asking for resource RA, one copy of resource RA. अगर 2 copies पूछेगा तो I will have 2 edges. अगर 3 copies पूछेगा तो I will have 3 edges. This is request edge. Claim, request. Claim is solid line, request is broken line. फिर उसके बाद reverse है assigned edge. So assigned will go from the resource to the process. Assigned will go from resource to process. Like for example, we say the process is assigned a copy of resource RB. Process I is assigned a copy of RB. So I will put from one dot. अगर 2 copies assigned हो गए तो I will have 2 edges. Multi-graph है, resource allocation graph is a multi-graph. So boys and girls, this is the definition of resource allocation graph. So how do you characterize deadlock with respect to resource allocation graph? Resource allocation graph. उसके लिए हम यहाँ पर कुछ example लेंगे. So all this I've already explained to you. A set of vertices V and a set of edges C. V is the partition into 2 types. These are threads या process कहो. Then resources, request edge, assigned edge, I have already told you, right? So this is an example of one sample resource allocation graph. This is one RAG. Let's call this as graph G1. So here I will show you. Now there is some dislocation of the vertices. I will call this as T1, this is T2, this is T3, this is R2, this is R1, this is R3, this is R4. There are 1, 2, 3 processes. I'm repeatedly writing. Process and threads are interchangeable. Process and thread is interchangeable in the chapter of deadlock. जहां पर भी आप thread बोलोगे, इक्विवेलेंटली विदाउट लूजिंग एनी जनरलिटी आप बोल सकते हो प्रोसेस, या जहां पर आप प्रोसेस कह रहे हो वहां पर आप इक्विवेलेंटली रिप्लेस कर सकते हो थ्रेड. So boys and girls, if you study this graph, there are three processes, there are three threads, T1, T2, T3. There are four resources, R1, R2, R3, R4. These two are single instance, one dot. These two are multi-instance. Process P1 is a requesting copy of R1, which is right now with process T2. T2 is requesting copy of R3, which is right now with process T3, and likewise others. तो अगर यहाँ गौर करो आप, the process P1 and P2, thread T1 and T2 are blocked because it is waiting for request, it is waiting for request or resource. Whereas T3, the thread T3, process T3 is not blocked. Why? It is not requesting anything. तो हम यहाँ पे कह सकते हैं कि the only process, the only thread which is runnable here is T3. अगर मान लीजिए thread T3 starts running on CPU. Imagine thread T3 starts running on CPU, and after some time it requests, after some time it requests the resource R4. Can it be granted? हाँ sir, granted. So grant it. It can be granted. It can be granted. So I will have assigned edge. After some time it will request, let's say resource R2, I put a request edge. And the moment I put request edge, the thread T3 or the process T3 will get blocked. Why will it get blocked? Because none of the copies of R2 are free, so therefore it will get blocked. अब यहाँ पर अगर आप गौर करो, all the three threads T1, T2, T3, all the three processes P1, T1, T2, T3 are blocked. And is there any chance, is there any possibility for these processes, for these threads to come out from block state? क्या ऐसा हो सकता है? It's not possible. Do we have a cycle here? हाँ sir, we have a cycle. Can we write the cycle? Let us write. Starting from T1, then I have R1, then I have T2, then I have R3, then I have T3, then I have R2, then I have T1. So there exists a cycle, boys and girls. There exists a cycle. This is a cycle. This cycle implies deadlock, because there is no possibility whatsoever for the processes to come out from their block state. कोई possibility नहीं है कि processes अपने cycle से बाहर आए. So therefore this indicates a deadlock. तो ये ग्राफ में आप गौर करो, there is a cycle, there is a deadlock. लेकिन हमने कहा था, if you remember, every cycle is not deadlock. उसके ये proof करने के लिए I will take another example. Have a look at this. So this is a cycle demonstration which I told just now. Processes P1, P2, P3 forming a cycle leading to a deadlock. Second example, I would like you to have a close look at this resource allocation graph, boys and girls. There are four processes, P1, P2, P3, P4. There are two resources, R1 and R2. Both the resources are in use, both the copies are in use. Lekin question is at time T0, imagine this is the current time T0, this is the current time T0. Kya at time T0 do we have a cycle? Yes sir, we have a cycle. कौन सी cycle है? We have a cycle involving processes like P1, R1, P3, R2, P1. We have a cycle. But this cycle does not imply deadlock. Sir, आप कैसे कह सकते हो कि this cycle is not proving deadlock? Why? Very simple. Because there is a possibility to break the cycle. Sir, कैसे? P2 is not blocked, P4 is not blocked. अगर आप मान के चलो P2 is going to complete its execution in finite amount of time, then it will release this copy of R1 that can be given to P1. P4 may complete and that copy can be given to P1, right? And that can be given to P3. So therefore, I can break the cycle. तो कहने का मतलब ये है, ये जो resource allocation graph है, यहाँ पर there is a possibility to break the cycle. लेकिन पिछली जो resource allocation graph थी, there was no possibility to break the cycle. देखिएगा, यहाँ पर साइकिल को आप ब्रेक नहीं कर सकते, लेकिन इस एग्जांपल में आप साइकिल को ब्रेक कर सकते हो. तो जिस ग्राफ में आप साइकिल को ब्रेक कर सकते हो वहां पर डेडलॉक नहीं है. जिस केस में आप साइकिल को ब्रेक कर सकते हो वहां डेडलॉक नहीं है, और अगर साइकिल को आप ब्रेक नहीं कर सकते तो वहां पर डेडलॉक है. तो एवरी साइकिल इज नॉट डेडलॉक बट एवरी डेडलॉक इंप्लाइज साइकिल. इसका एग्जांपल मैंने प्रूफ किया है. So based on this I can formulate some simple facts. The simple facts are that if graph contains no cycles, no deadlock. First important point. This is a very important observation. Let us highlight it. Let us highlight it. If graph contains no cycles, no deadlock. हाँ, second point. If graph contains a cycle, अगर एक ही instance हो, if we have only one instance of the resource, then it is a deadlock. So boys and girls, in case if my resource allocation graph has single instance resource, then cycle is a necessary and sufficient condition for a deadlock. मतलब every cycle is a deadlock in this case. लेकिन if there are several instances, if there are multiple instances, boys and girls, if there are multiple instances of the resource, then cycle is only a necessary condition. Deadlock may happen, may not happen. यहाँ पर हम लिख रहे हैं possibility of deadlock. So here यहाँ पर necessary and sufficient condition, necessary and sufficient. और यहाँ पर है यहाँ पर है only necessary. ये है fundamental difference, characterization of cycle and deadlock, necessary condition. So this is the relationship between cycle and deadlock, characterization in resource allocation graph of a deadlock with respect to cycle. तो ये है philosophy of deadlock. अब नेक्स्ट हमें डिस्कस करना होगा मेथड्स फॉर डीलिंग विद डेडलॉक, डेडलॉक हैंडलिंग स्ट्रैटेजीज. सो आई विल राइट डेडलॉक हैंडलिंग यहां पे लिखेंगे काफी बड़ा चला गया है, ठीक है. तो लेट अस राइट इट विथ रनिंग हैंड ओनली. डेडलॉक हैंडलिंग strategies. What are general approaches for dealing with the problem of deadlock? That's the meaning. So if you find in the literature, if you see the literature, there are several approaches for dealing with the problem of deadlock. एक एक करके लिखेंगे, फिर अंडरस्टैंडिंग डेवलप करेंगे. The first is called deadlock prevention. Deadlock prevention. The second is called deadlock avoidance. And the third one is called deadlock detection and recovery. Deadlock detection and recovery. And the last one is called deadlock ignorance. Deadlock ignorance. So boys and girls, I would like to tell you that these are categorized into two types like this. This is one type of strategy and this is another type of strategy. So we need to demarcate, we need to differentiate between these two types of strategies. I will call this as this is type 1 approach, this is type 2 approach. तो बच्चों फंडामेंटली क्या डिफरेंस है बिटवीन टाइप 1 एंड टाइप 2? अगर आप कीवर्ड्स पर फोकस करो, प्रिवेंशन, अवॉइडेंस, डिटेक्शन एंड रिकवरी एंड इग्नोरेंस, डिफरेंस आप ये कह सकते हो कि इन टाइप 1 स्ट्रैटेजी अगर हम यूज करेंगे सिस्टम में, डेडलॉक नेवर अकर्स. डेडलॉक नेवर अकर्स बिकॉज यू आर गोइंग टू बी प्रोएक्टिव इन नेचर. यहां पर प्रोएक्टिव अप्रोच है ये. आप पहले से ही केयरफुल इनफ not allow the system to go into deadlock. Proactive. Never allow the system to go into deadlock. Prevent it or avoid it. Approaches अलग अलग है दोनों के. Deadlock detection and recovery मतलब deadlock happen. यहां पर deadlock होगा. Deadlock occurs. Therefore, you are detecting and recovering. ये reactive है. फिर last approach is deadlock ignorance. Deadlock ignorance. Deadlock ignorance का मतलब no strategy. So deadlock ignorance का मतलब there is no strategy. So let me write. Ignorance is no strategy. So this is like inactive, no approach. This is proactive, reactive and no active. You are not going to take any action when deadlock happens. all right. And this algorithm of deadlock ignorance popularly in the literature is known as ostrich algorithm. This is based on ostrich technique. Why? Because when ostrich see a problem like sandstorm in desert, it does not take any concrete way or concrete strategy to deal with the problem. It will hide its or put its head inside the sand and closes its eye, thinking that nothing will happen, problem will be automatically solved. That is called ignorant strategy of ostrich. So if in case if operating system is not using any strategy, that approach for dealing with deadlock is called ignorant strategy, just like ostrich algorithm. This is invariably also adopted in most of the contemporary desktop operating systems, including Windows, Unix, and Linux. Because the overhead is more for adopting or applying deadlock handling strategy, so most of the contemporary operating system, Windows, Unix, and Linux, they also use ostrich algorithm. So this is the taxonomy. This is a classification of various deadlock handling strategies. Prevention, avoidance. Avoidance का फेमस जो एल्गोरिथम है वो है बैंकर्स एल्गोरिथम, फेमस एल्गोरिथम. लेकिन from gate examination perspective, let me tell you, all these strategies are important. All these strategies are important, and we are going to make a detailed discussion of all these strategies in subsequent sessions. तो आज के लेक्चर में बस इतना ही. यहाँ पर नेक्स्ट सेशन में मैं आपको डिस्कस करूंगा डेडलॉक प्रिवेंशन एंड डेडलॉक अवॉइडेंस बैंकर्स एल्गोरिथम. ओके, टेक केयर, थैंक यू.